Okay, so for my test replacement project, I'm going to make a video explaining how to do fun example number 5 from Unit 1, which was kinematics. So, fun example number 5 says, Bunk loves to play with his frisbee. He runs 50 meters to the right of me to catch his frisbee and turns and runs 75 meters back to return it. If this takes place over 20 seconds, A, what is his final displacement? B, what is his average speed for the whole trip? And C, what is his average velocity for the whole trip? So, the way that I would begin this question is by drawing out what Bunk did, making a diagram. So, if this is where Miss Smith is standing, Bunk initially runs 50 meters right to catch the frisbee. Then he runs another 75 meters from that initial, or from that final position, 75 meters, and ends up to the left of Miss Smith. So, the first part of this question asks what his final displacement would be. And displacement is different from the distance, which is a common misconception. So displacement is a vector quantity defined as the change in position of an object, how far an object is from its starting position. So it would not be the distance that Bunk traveled, meaning it wouldn't be 50 plus 75 meters. It would be the distance that Bunk ends up, which this is his final position, from his starting position, which is at Miss Smith. So, as an example, that would be different if Bunk ran in not a straight line. This would be the distance. If this was Miss Smith at A and his final position was at B, that would be the distance, but that would be the displacement because it's the amount of space that Bunk traveled. So, to find displacement, the equation is the change in x equals f of x minus x initial, where f is the final position and I is the initial position. So, to solve this, you would find the change in x by x final, which is 75 meters, minus his initial position, which we know would be 25, because if Bunk runs 50 meters to the right, then back 75 meters, we know that the space from Miss Smith to his final position would only be 25 meters. So we would find 75 minus 50, because that is the other position that he ran, and the change in x would be 25 meters, which we just discussed. So, Bunk only ended up 25 meters away from Miss Smith in the end. So, the next part of this question asks us to find the average speed for Bunk's entire trip. So, average speed is the total length of the path an object takes divided by the time it takes to travel the distance. So that would not be talking about displacement. We would now be talking about the distance, which the distance would be 75 meters plus 50 meters because he traveled 50 meters to the right and 75 meters to the left. So, total distance would be 75 meters plus 50 meters, which would be 125 meters. We are given in the question that it takes Bunk 20 seconds to catch the frisbee and run back 75 meters towards Miss Smith. So, average speed is found by path length, which is the distance, divided by the time. So, if we know that Bunk traveled 125 meters, that's his distance, divided by 20 seconds, we can determine $125 divided by 20 would be 6.25 meters per second. And average speed is always found in meters per second. So, the final part of this question asks us to find his average velocity for his entire trip. Average velocity is different than average speed because average velocity is talking about the displacement of the object. And it includes magnitude and direction. So, a definition for average velocity is used to represent the magnitude and direction of an object's motion and is defined in terms of displacement rather than distance, which that is the biggest difference between average velocity and average speed, which is very important to know. So, for part C, the equation for average velocity is velocity equals the change in x over the change in time, which can also be defined as xf minus xi over tf minus ti. So, we already found in part A his displacement, which is also shown by the change in x. So, if we know that 25 meters over his change in time is 20 seconds, we can also determine that 25 divided by 20 would be 1.25 meters per second, which average velocity is always found in meters per second as well. So, hopefully it is clear how to solve fun example number 5.